So this lesson is a quick overview of basic electrical circuits and Ohm's law. As you hopefully remember, any electrical circuit has a few minimum components. The most basic would be a power supply, and that can be represented, a DC power supply would be possibly represented as a battery, like that. That represents the plates in the battery, and the end of the symbol that has the longer line there is always considered the positive by definition. An AC source could be represented by a circle with a sine wave in it. And just as a review, AC wouldn't have a positive or negative, right? That's the general idea. It's alternating current, always switching back and forth between positive and negative. So we have to have a power supply at a minimum, either AC or DC. What else do we need to have? We need to have conductors. So let's say we had our DC power supply, and we just connected it from one end to the other with conductors. And this is a 12-volt supply. That supply wouldn't last very long unless it was fused, because we've now connected a path from one end to the other with essentially no resistance in it. So it's going to flow as many electrons out as it can in a hurry, and most likely it will either burn up the power supply or melt the conductor. So we need to add some additional components to have a circuit that's actually useful to us. So we can, again, let's start with our power supply. But now we're going to say we want to add both an input and an output device. So in this case, let's say I want to add a push button. There's one of our schematic symbols for a push button, and it's going to control, let's say it's a lamp. If you remember, kind of filament. So now we have a circuit. It consists of our power supply, an input device that controls whether current can flow in the circuit, and a load. So in this case, when we push the push button, representation would be that bar is coming down, connecting those conductors, and current can flow through the circuit as an entire path. So it's a really basic circuit. Obviously, could be lots of different input devices. If you remember back to MEC 133, float switches, pressure switches, selector switches, limit switches. Those are all mechanical devices in general. The inputs could also be an electronic device, like a proximity sensor, a photo eye, ultrasonic sensor, that kind of thing. Again, same thing with our outputs. I just had a lamp here, but it could be anything to a control relay coil, motor, starter, any kind of output potentially. So that gave us an overview of the pieces of the circuit. Let's now refresh our memory about Ohm's law, kind of one of the basic rules governing the properties inside a circuit. So Ohm's law, Ohm, like the unit of resistance, if you remember, says that the voltage is equal to the current at a point times the resistance across which you're measuring the voltage. So let's do a quick example of a circuit to use that. Let's say we have an AC voltage source, and let's say it's 240 volt AC in this case. And let's say it's running through a switch we've got, and it is powering a resistive heater. Let's say maybe heating up a control cabinet, something like that. And let's say the load or the resistance of that heater is 10 ohms. Again, that omega symbol for ohms representing resistance. So we can see that if we look up at Ohm's law, we've got the voltage is equal to 240 volts, and we've got the R, the resistance, is 10 ohms. So our unknown in this point would be the current in amps. So we can rearrange that equation to solve for I. So that would, if we start with the default there of E equals I times R, just to refresh rearranging that equation, we need to get I by itself. So that means we would divide both sides by R, right? And that's going to lead us to current is equal to the voltage divided by the resistance. So we can plug in the values we have for voltage and resistance here. So I is going to be equal to 240 volts divided by 10 ohms. So in this case then, the current is equal to 24 amps. And that would be useful to us if we're sizing the wires, checking to make sure that they can handle the current, or we're sizing fuses or circuit breakers. That ability to switch or to find current, voltage, or resistance, if we know the two others, is kind of a key basic understanding of electronic circuits. So we'll go over one other equation governing these would be power. So again, if you remember back, a power law says that the power in a circuit is equal to the voltage times the current. So this can be useful to you because some devices are rated in their power, typically in watts or kilowatts then. So let's do an example of how we would use the power law in the PLC arena. So let's say you were told that you had an off-the-shelf power supply for your PLC project and you wanted to know if it would be appropriate and big enough for the particular project. Let's say you were told that it was a 24 volt power supply and that it was 120 watt capacity, but it didn't say on it how many amps it could give out. So this is what you're given as far as your supply information, 24 volts at 120 watts. Then you also know that you're going to have a PLC rack that has cards in it, and each of those cards is going to have a current draw, a requirement that it's going to put on the power supply. So let's say you have 4 cards and they each draw, let's say, 1.5 amps. 4 cards at 1.5 amps each. So that's going to be a total of 4 times 1.5 of 6 amps. So you don't have an amp value for your power supply for your source. You have one for your draw. And now you need to figure out, okay, can my supply I've got do that? So we have our P, that's 120 watts. We have our E, that's 24 volts, but we need to solve for I. So rearrange that equation to say that I is equal to the P divided by E. And so in this case, that's going to be the power was 120 watts divided by the voltage of 24 volts. So I'll bring that over here. 120 divided by 24. So it can put out, I don't know if you can see that, 5 amps. So our supply is good for 5 amps and our cards are going to draw 6 amps. So in this case, that supply is not going to work. We would need to get the next size larger. So hopefully that's helpful as a quick reminder and review of Ohm's law and the power law. Just want us to kind of get back into thinking about electrical circuits, what we need as power support, power source, conductors, input devices, output devices. Now that we're in PLCs, we're going to more often have a lot of inputs connected to the PLC on one side, the input side of the diagram, and then all our outputs on a different side. So our schematics will look different than they have in the past. But the same electrical principles are happening. What's going on inside the circuit, the currents, the voltages, the resistances, etc. So key idea to remember, takeaway, memorize Ohm's law, understand how power works. Remember that in any circuit, if the voltage goes up and the resistance stays the same, then the current's going to go up. And the same thing kind of idea, if the resistance goes down in a circuit and the voltage stays the same, the current's going to go up in that case too. So those are both situations where you'll want to be cautious. Anytime that voltage is increasing or resistance is decreasing. That can be either intentionally in a circuit or if something's going wrong. Resistance going down, that can be somebody accidentally shorted something out and that's going to make your current go up in a hurry. Hopefully it'll blow a fuse or a circuit breaker before it does something to permanent equipment. But just keep that those kind of ideas. Increase in voltage, increase in current. Decrease in resistance, increase in current, because current is what kills devices. Okay, I hope that's a quick review is helpful. Let me know if you have any questions on Ohm's law, power law, etc. Thanks.